Hello everyone, my name is Alan Medlar and I'm here to present our paper, Behind the Scenes, Adapting Cinematography and Editing Concepts to Navigation in Virtual Reality. I'm here on behalf of myself and my colleagues Marie Lehtikari and Dorota Glowacka, and we're all from the University of Helsinki in Finland. So our work is motivated by how users move through virtual environments, which for many users is limited to teleportation. That we're showing on the screen now. So this is because continuous motion, more closer to something that you would experience in a video game, gives many people VR sickness, so they experience symptoms like nausea, maybe even disorientation. But teleportation avoids many of these issues. Now, unfortunately, several studies have suggested that teleportation can actually reduce spatial awareness as users navigate through the environment. So this causes them to miss important aspects of their surroundings, and it introduces the need to constantly reorientate themselves immediately after teleportation. So we noticed a connection between these issues in teleportation and a cinematic technique called continuity editing. So the goal of continuity editing is to connect sequential shots in such a way that it advances the narrative while maintaining the viewer's understanding of how the scene fits together, both temporally and spatially. So I just showed a very brief scene from about halfway through Fritz Lang's 1927 movie Metropolis. And we're going to use this as an example to understand what continuity editing is trying to achieve. So I'm going to re-show this short shot again, but this time the shot on either side of the cut is going to be kept separate. And what we want to do is we want to emphasize the creative decisions that the director made when moving from shot to shot. So here he's applied what is called the 30-degree rule. And this is where the angle between two camera positions is at least 30 degrees. So when we cut between those two shots, the goal is that they're different enough to engage the viewer in the story that they're experiencing, but they're also different enough so that the end result is not confusing to them. It doesn't make them think that the scene is orientated differently from what they had originally expected. Now, how are we going to connect this to virtual reality? What we did was we reconceptualized the actual moment of teleportation in VR as a cut. And then when we do that, we can apply the rules of continuity editing. So all of these techniques like the 30-degree rule, the rule of thirds and others, with the goal of increasing user engagement and hopefully promoting spatial awareness of the surrounding virtual environment. So we designed a new navigation method called Active that is based on teleportation to experiment with these ideas. So in Active, the user selects a target position and teleports as usual. Next, we reposition the camera, and last, we reorientate the camera to reframe any entities that are currently visible on screen. So repositioning uses two editing rules that are applied deterministically, whereas reorienting the camera uses multi-objective optimization to identify the best angle. The reason for the difference between applying repositioning rules deterministically versus reorientation rules probabilistically is because we wanted to limit the actual state space as we would need to make this calculation essentially within 1/60th of a second. So in general, this procedure only makes quite subtle changes to the positioning and the orientation of the camera. However, sometimes the results could be potentially disorientating. So for example, this is the environment that we used in our study. And the user at this starting point might want to teleport to a position between themselves and the statue. Now, the problem here is that while regular teleporting simply moves the user to their desired position by performing a translation of their current position to their destination position, what Active does is it repositions and orientates the camera, which in such a narrow space as we see here, causes the position to be changed quite close towards the statue in order to satisfy the rules of continuity editing. Now we recognise that this maybe has the potential to reduce users' sense of control and could also cause disorientation and maybe in the worst case scenario, VR sickness as well. So these considerations informed our research questions. So first, for our research questions, we wanted to understand whether active would, as we hoped, increase users' spatial awareness of the virtual environment. So we split this into user engagement with the VR application itself, just in general, and secondly, the user's ability to recall the contents of the scene, which for our purposes we defined as the statues that were placed throughout the environment. Second, we wanted to understand whether we'd inadvertently introduced more problems. So we were interested in whether active impacted any of the symptoms of VR sickness, like whether it made people feel disorientated or nauseous. And lastly, we wanted to know whether it affected their sense of involvement and control as they navigate through the environment. So this is a particular aspect of presence, which is one of the key measures of user experience in virtual reality. We evaluated active in a between-subject study with 40 participants. The virtual environment was this industrial setting, and we had 20 statues that people needed to navigate to be able to perform the recall questionnaire later. We used a MetaQuest 2 headset, so there were no cables connecting to a host computer to prevent people from turning around. The measures that we collected was the UES, User Engagement Survey, to measure different aspects of user engagement. We created a queued recall questionnaire based on the statues that were present in the environment and statues which were not present in the environment. Users were given the simulator sickness questionnaire before and after using the application to measure any difference in VR sickness. And lastly, we used the presence questionnaire to measure users' sense of involvement and control, but we removed all of the other constructs, so because there were no differences in audio or haptics between the two experimental settings. So I'll just give a brief overview of results before then summarizing the conclusions that we drew from this. So first, there were no significant differences in VR sickness between active and teleportation. And second, there were no differences in their sense of presence, at least one when measured by their sense of involvement and control. So these were both as we'd hoped. Unfortunately, there was no difference between queued recall between the two, but as I'll mention in a few slides, in general, there's mixed results in virtual reality research about whether immersive environments actually have an influence have an effect on user recall. But for user engagement, active improved the total UES score by 8.6%, so this was highly significant, and it was driven by a 17.6% increase in the aesthetic appeal subscale. So when we look at the individual items for aesthetic appeal, active actually scored between 10 and 55 percentage points higher than regular teleportation, which is very significant. So based on these results, our first conclusion is that concepts from continuity editing can be used in VR applications to make them more engaging experiences. Now, we thought this was particularly interesting because, unlike watching a movie, in VR the user is in control of when and where they teleport to and ultimately where they're looking. So even with active, while we reframe the scene, reorientate the camera, this really only lasts for a split second for the user, because they're constantly moving their heads around, looking at the elements of the scene, in order to continue navigating and to actually perform their task. So it's quite surprising that it has such a big effect on their sense of aesthetic appeal. Second, increased user engagement does not translate to improved recall. So there's two aspects to this. First, one limitation of our study is possibly that the statues themselves that we used as points of interest were particularly memorable. They stuck out in this industrial setting. Second, it was also brought to our attention that there's kind of mixed results in VR studies about whether immersive environments can actually improve recall. But this isn't particularly clear. I mean, there's no standard way to measure recall in VR, with some studies asking about the contents of the scene, as we did, and others looking at downstream things like users' actual learning outcomes. And lastly, while repositioning and reorienting the camera clearly takes away some agency from users, it doesn't appear to really impact their sense of presence, it doesn't appear to exacerbate the symptoms of VR sickness. And we feel this could potentially open the door to thinking about what the limits are for VR experiences where, even though users are in control, how the application works or how the world is experienced is a lot more guided, and there's a lot more control on the part of the designer and the application developer. So, thank you for listening to this presentation. I hope you enjoyed it. I'm very sorry that I was not able to come to Hawaii to present in person. And here's our contact information if you want to get in touch. Thank you very much.